Alright, so today what we're going to look at is Pythagorean triples. So in a minute what we're going to do is we're going to use some of our ideas of special right triangles and the Pythagorean theorem to help solve right triangles. So if we remember the Pythagorean theorem, so if I have a right triangle and I have A, B, and C as my sides, I can use A squared plus B squared is equal to C squared. So I can solve for any one of the sides as long as I know 2 out of 3, right? I also have special right triangles. So remember I have the 30, 60, 90 special right triangle. So depending on how that is made, again, it has to be a right degree. So 30 and 60. And so off of the 30 degrees, we just have one of our letters, we'll call it X. Off of the hypotenuse, it's always double that length. And then off of the 60 degrees, it's always that small length times a root 3. Remember, if you need some extra help on 30, 60, 90, please check out the video on special right triangles. And then the last one was your 45, 45, 90 degree triangle, aka the isosceles triangle. So again, this is 45 degrees, which means this side is the same as that side. And then if this side is x, the other side has to be x. And then this is x root 2. All right, so using these 3 ideas, what I want you to do is I want you to take a look at these 9 problems. And I want you to come up with the missing side lengths. So find all missing sides. Okay, and then I want you to think, are any of the triangles kind of similar to each other? Okay, so go ahead and pause the video now and work out these 9 problems. All right, so if we're coming back from our video, let's go ahead and work out a few of these. So if this is the 12, so using our 30, 60, 90, this means that this would be my 30 degrees. Off of my 30 degrees would be half of 6, or sorry, half of 12, which is 6. And then this guy would be your 6 root 3. And we can always check to make sure that that is correct by using the Pythagorean theorem. All right, part B, if this is 3, that means that this also is 3. And then this would be 3 root 2. For part C, I would use 3 squared plus 4 squared is equal to, let's just call it x squared. So 9 plus 16 gives you 25. So x has to equal the positive version of 5. So that's for letter C. For letter D, I'll put that over here. So D would be 8 squared plus 6 squared is equal to x squared. So 64 plus 36 gives me 100 and equal to x squared. So that means that the square root of 100 is 10. All right. E has 30 degrees, which means that this guy is 60. So it's very similar to A. So if I know the small length is 4, then I know the hypotenuse is double that length. So if I double 4, I'm going to get 8. And then off of the 60 degrees will be the small length, 4, times the radical of 3. Okay, moving on to letter F. So I'll put letter F up here. So I'm going to say 5 squared plus 12 squared is equal to x squared. So 25 plus 144 is going to give me 169 as x squared. If I take the square root, that will give me 13. Okay, now I want you to notice that G, really large numbers. So I really hope that we didn't take out a calculator and try to figure out what is 3,000 squared and 4,000 squared, right? I don't think we should have done this because I don't really care what 3,000 squared is and what 4,000 squared is. Hopefully what you notice is that G and C are very similar to each other. The only difference is they added 3 zeros. So if I add 3 zeros to this, I'd add 3 zeros to this. Technically, I'd add 3 zeros to 5,000, or sorry, to 5 to give us the 5,000. Okay. Moving on to letter H. Again, notice that these numbers are really large. So maybe this time you did get a calculator out. So 36 squared plus 15 squared is equal to x squared. Let me grab my calculator and drag it over here. So 36 squared plus 15 squared gives me 1521. And I'm going to take the square root of 1521, which gives me 39. So 1521 x is equal to 39. So I get 39. Now, hopefully what you noticed is that this guy, H, oops, let me, different color, is that H was actually similar to F. So notice that 5 and 15, this is really 5 times 3. Notice that 12, if I do 12 times 3, I'm going to get 36, so 39 should be 13 times 3. Okay, so that's fun. And our last one, I, so again, 41 squared. This time it's the hypotenuse, so let's say it's equal to, so letter I is equal to x squared plus 9 squared. Again, 41 squared. Let's figure out what that is. 1681. So 1681 is equal to 81 plus x squared. So x squared is equal to 1600. And the square root of 16 is 4, which means the square root of 1600 should be 40. Okay. So there are some patterns already emerging with this. Okay. Now, if we recall, this lesson is called the Pythagorean triple. So let's come up to a new page. So Pythagorean triple. And one of the Pythagorean triples is the 3, 4, 5. That is an example of a Pythagorean triple, which we can see in example letter C. Okay, G is just a larger triangle of C. Another Pythagorean triple that we see is letter F. So we were going to say the second one will be 5, 12, and 13. Now, why do we think this is called a Pythagorean triple, or Pythagorean triples? Okay, what a Pythagorean triple is, so we can say this, a Pythagorean triple, it describes 3 integer side lengths of a right triangle, right? And so sometimes if we already know that 3, 4, 5 go together, right, then I don't have to worry about using my Pythagorean theorem to try to figure out what the missing side length is, right? So it is important to kind of memorize the basics, so 3, 4, 5, 5, 12, and 13. Do we see another Pythagorean triple up here? And the answer is yes. Hopefully we did notice that letter I was also a Pythagorean triple. So let's add letter I to a Pythagorean triple. So that was 9, 40, and 41. Okay. There's a couple other Pythagorean triples that we have. So these are the first 3 that came up, and ones that we can also use. Important would be 7, 24. 25, so you can check that out on your own. You can also say that it's 8, 15, and 17, so again, all integers. And then just one more, let's do 11, 60, and 61, right? There's a lot of Pythagorean triples out there to remember. I would say the first one is used the most, right? And the second one is probably used the second most. Out of the remaining 4, I definitely see 3, 4, and 5 used more than I see number 6. So now that we know that this is a Pythagorean triple, let's go ahead and still using our special right triangles for 30, 60, 90, and 45, 45, 90. But let's see if we can solve for, again, the missing length. So again, let's say find the missing side lengths. All right, so go ahead, pause that video right now and see if you recognize anything. All right, so hopefully at this point we've tried a few. If we're not done, again, pause that video. So for A, so this one's a little bit trickier. So I'm given the hypotenuse, and what's half of 13? We should have said 6.5, right? Or what we can say for letter A, when I have my lovely triangle out. So again, here's my 30 degrees and 13. I can just say that that's 13 over 2. Perfectly fine, right? Which means that if I keep it as a decimal, this will become 6.5 times root 3. Or if I write it like this one, this will be 13 root 3 all over 2. So either one for letter A. Okay, for B, hopefully what you recognized was between 18 and 24, there's a 6. So this is really 6 times 3, and this is really 6 times 4, right? So there's 6's. So this is a 3, 4, which means that this should be 6 times 5. So this will be 30. So this was our special right triangle of the 3, 4, 5 triangle. Okay. For C, 45, 45, which means that this side is exactly the same as that. So 25, which means that this is 25 root 2. Moving on to D. So 30 degrees is the 7. So if I double the 7, I'm going to get 14. And then I'm just going to say that this is 7 root 3. All right, now between the 20 and the 52, right? Again, huge numbers, but what you should have recognized is that 20 is made up of 4 times 5, and 5 is part of my Pythagorean triple, which means if I look at 52, this is really 4 times 13. So this is your 5, 12, 13 triangle. 5, 12, 13 triangle, which means that this guy will be 4 times 12, which is going to give you 48. So again, I'm trying not to use my calculator to double check my answers. Now F is a little bit more challenging. We have to remember that these are exactly the same, and this guy is really equal to x root 2. So if I just say 6 is equal to x root 2, that means I'm going to divide both sides by root 2, and I'm going to get 6 over root 2 for both of my sides. Now, in a previous video, we did rationalize the denominator. So if we were going to do that again, I multiply top and bottom by root 2. So I'm going to get 6 root 2 all over 2. 2 goes into 6 3 times. So this is the same thing as saying 3 root 2. So either one is perfectly fine. Okay, in our next video, we're going to try some more challenge problems that are a little similar to these, using our Pythagorean triples as well as our special right triangles.